In this video, I'd like to talk about the math question of the day for Tuesday, August 8th, 2023. And with this problem, we need to graph this equation, 9x plus 15y is equal to 45. And typically, graphing linear equations when they're in standard form is something that's taught in an Algebra 1 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's try to graph this equation here. And we know it's in standard form because the x and y variables are on the same side of the equation. And we know it's linear because x and y are both to the first power. We don't have any x squared or y squared. We're not multiplying x and y. We don't have any trigonometry or division by x or y. So in that case, we know that this is linear. And there are a couple different approaches that we can take, but let's start by first making a coordinate plane. Now, the simplest approach to graphing these linear equations is to make a table. We can just plug in different values of x and y, and then plot their coordinate points. And when the equation is in standard form, it's especially helpful to look for the intercepts. Namely, when x is 0, we need to find the y value, and when y is 0, we can find the x value. We can plot those 2 points and then connect them with a line. And in standard form, it's simple to plug in 0. Since when we plug in 0 here, this just goes away and we get 15y is 45, which we can solve quickly by dividing each side by 15. And by doing that, we would get 3. So when x is 0, y is equal to 3. And let me keep that in the green color. Now, we can plug in y is 0, meaning that this term will vanish, and we'll get 9x is equal to 45. So let's do that right here. We get 9x is 45. And dividing each side of this equation by 9, we will get that x is equal to 5, which we can plug in right here. Now, let's plot these points. We have an x value of 0 and a y value of 3, and an x value of 5 and a y value of 0, and we can connect these with a line. Though I will save that, since I do want to mention the second technique that is equally effective, though it might take a little bit longer. But the general strategy there is that we want to solve this for y so that we can put it in slope-intercept form. And remember, slope-intercept form is just y is equal to mx plus b, where m is the slope of the line, which remember is defined as the rise divided by the run, or essentially how much the y values change divided by how much the x values change. And b is just the y-intercept. It's the y value when x is equal to 0, since if you plug in 0 here, this term goes away, and y is equal to b. Now, solving this for y, let's subtract 9x, and let me work on that. Down here, we have 15y is equal to minus 9x plus 45, and we'll divide everything by 15 and simplify the fractions. 9 over 15, each of those are divisible by 3, so we get minus 3/5 x, and 45 divided by 15, that is 3. Now, with slope-intercept form, we start at the y-intercept when x is 0, which again is this point right here at 0, 3. And then we use the slope to find the next point. And our slope is minus 3/5. Our rise is negative 3. We go down 3, and our run is 5, meaning we go all the way to this point here. So in both cases, we'll end up plotting the exact same 2 points, which at that point, we can just connect with a line. So this right here, this line is the graph of this linear equation, 9x plus 15y is equal to 45.